Next instructions that we want to talk about are these four. The first one and second one, they use the indirect addressing mode, and the third and the fourth use the direct addressing mode. And whenever you see LD or load means that the destination is a register inside the CPU, and well, the source is obviously the memory. Whenever you see STA or store, it means that the source is the CPU. So here the destination is the A register, the first one. The second one is also the A register, and the last one is also a register. But the third one, the destination is HL register pair. It's still the CPU because it is loading a value from memory to the CPU. The opcode is this, again, because we have four different instructions in this format. We need only 2 bits to distinguish all of them. So this would be 00, 01, 10, and 11. And obviously the opcode of this would be 1010 or 0A, and this would be 1A, 2A, and 3A. About the length of them, well, we explained before in the indirect addressing mode, because somehow we are implying things, the length of the instruction would be 1 byte. This would be also 1 byte, but this one, because the programmer needs to provide the address from which we need to retrieve the data in the registers in the CPU, and the addresses are 16 bits. So one byte for the opcode and 2 bytes for the addresses. The length of the instruction would be obviously the longest in the 8085, which is 3 byte. Now, let's now talk about the result, and then talk about the steps or machine cycles that they would take to get executed. So the first one, it would be the memory cell which BC contains. Its address should go to the A register. In other words, the CPU would put the contents of the BC register pair on the address bus, causing a memory cell to be selected. Then the data from that memory cell, in every memory cell we have only 1 byte, right? The data, the 1 byte in that memory cell, would be brought inside the A register. So one fetch step we would have for this instruction to fetch the opcode. Then the CPU would put this on the address bus, right, and would do a read. So one fetch and one read would be the 2 steps or 2 machine cycles done to execute this instruction. Later, we would get the steps for each machine cycle and the exact time that they would get to execute. Next one, it would also be the same, with the difference that the DE register pair would select a memory cell inside the A register. Everything else would be the same. The last one, the ADDR that the programmer chooses, would select a memory cell, and the data would be brought inside the A register, but the steps would be different. Why? Because we need one fetch to fetch the opcode, but then 2 bytes of the ADDR, they need to be read. So one read, 2 read, and then the 16-bit address would be put onto the address bus, selecting a memory cell, and then that memory cell needs to be read inside a register as well. So we have 1 fetch and 3 read, compared to the first 2, which were only a fetch and a read. But the third one is different. The third one, you see, when you understand one of them, you could work out the logic. You don't need to remember anything. I'm not looking at any notes. I'm just looking at them, and by working some logics, like LD means load means the destination is the CPU, ADDR means the programmer should provide that. This is somehow implied, so the length would be 1 byte, and this is the format, only the format. I've written them here so that I could work out the opcode. But let's look at the third one, LHLD ADDR. So what this means is this. Let me just give you this with an example from the memory, because it is a bit more tricky than the first 3. So let's say this is our memory. In the first memory cell, we would have the value of 2A, which is the opcode of LHLD, then 2 bytes for the ADDR. Let's say that the programmer has written LHLD, then 2000, meaning that it wants to bring data from the address of 2000 and 2001 in the HL register pair. You see, in all of these three, the destination was only one register and had the capacity of 8 bits only. But here the destination is a register pair, therefore the capacity is 16 bits. If the destination is 16 bits, the source should be 16 bits. But here this 16 bits isn't the data. The data resides in this address, but we know that 1 byte resides in every memory cell. So 1 byte in this memory cell, but the CPU knows from the decoding phase of this opcode that not only it should bring the data in this address, but also it should bring the data in the address that follows the address of 2000. So let me just give you the complete example. So LHLD 2000, the programmer has written this. In the RAM, it is translated to 2A for the opcode, then 00 and 20. The reason that we have written this in this format is because of the Indianness, and we explained that lower byte, which is this, comes in the lower address. You see, this goes towards the higher addresses. Then higher byte would come to the higher address. So what the CPU would do is that the PC is pointing here. It would first fetch the 2A and put it inside the IR register. So far, the CPU has done one fetch. In the fetch and in the decoding, it would figure out that the next 2 bytes should be read and put on the address bus. So we have 1 read, 2 read, and both of them are on the address bus. Now, the data here that the address bus has selected, it would select the memory cell 2000, right? So the memory cell 2000 would be selected, and obviously a write would happen. This write would write the value in 2000 in the L register, not H register, in the L register. So 1 right here for the L register, then it would increase the value of 2000 to 2001, and this other, the byte in this memory cell would be also read. Sorry, this should have been read, and then the value in the 2001 should also be read and put inside the H register as well. So we have another read. So again, let's say, as the summary of all of this, let's say that in the memory here, let me expand our memory and change the color. Let's say in the memory, this was the address of 2000 and this was the 2001, and these were the addresses of like 4, 5, 6 and so on. In the 2000 we had the value of A0, and 2001 we had the value of 22. The goal of this instruction is to bring these two values in the HL register pair, but look at the logic that would be done. The first time fetch would happen, 2A is in the IR register. Then 1 read and 2 read would happen so that the whole address, the 2000, would be put on the address bus. So 1 read and 2 reads. Then 1 memory cell would be selected, which is the memory cell of 2000. The contents here would be read inside the L. Why L? Because we are talking about the HL register pair, lower byte, lower address. This is lower byte, right? This 2000 is the lower address. So A0 would be written inside the L register pair, and then, so that it was the third read, right? Then the address on the address bus would be incremented, selecting the 2001 address. Now the data here, which is 22, would be read inside the H register pair, and therefore the final read would happen. So 1 fetch and 4 read would be the summary of the instruction LHLD ADDR, which is the longest among these instructions. And then the value of the HL is now 22A0, Look how you don't need to remember or memorize anything. You just work out the logic. In 8085, everything works in this way, that lower address comes in the lower byte and higher address higher byte, both for the addresses and also here the data.